In the eighth and final problem, we recognize that again we just have something that is a polynomial, but it's not a quadratic. It's a little bit higher than that. But since it is a polynomial, we can identify, based on the degree of the polynomial, that we should have 3 solutions. So we know we got to find all 3 solutions to this. Well, there's not a special formula for dealing with something that has 4 terms. There's no quadratic formula type thing to use for that. Instead, we try to factor. In this case, we're going to factor by grouping. In the first group, there's a common factor of x squared that can be factored out. When I factor it out, I'm left with 3x plus 7. And you can notice inside here in the pink parentheses, these guys don't have anything else in common. 3 and 7 they're relatively prime. For the second group right here, your second group begins with a minus, so you need to factor a negative out along with whatever 9 and 21 have in common. Their common factor is 3. Not 9, not anything else. It's 3. Remember, whenever you are factoring that out, it's as though you're dividing that. So negative 9 divided by negative 3 is a positive 3x. Negative 21 divided by negative 3 is a positive 7. If you're not sure about this, just take a moment to distribute it back to see that it does check out. That's going to give you a negative 9x, and the negative 3 times positive 7 is a negative 21. In order to factor by grouping, these need to be the same. That is the big common factor that I'm now going to factor up front. So 3x plus 7. And the 3x plus 7 was connected to both x squared minus 3. All right, so we have this factored, and it's equal to 0. And so now we use that zero factor theorem. We make smaller equations from this. 3x plus 7 is equal to 0, or the other option is that x squared minus 3 is equal to 0. We go through the process of solving this guy over here. So you would first need to subtract 7, and then we finish getting x by itself by dividing both sides by 3. We were expecting to have 3 solutions. There is 1 solution. Over here, this is where you're going to get your 2 extra solutions because of the square. So we move the 3 to the other side, and we apply the square root property. The original problem here is not a square root property problem, but when you break it down into smaller pieces, the square root property shows up. So x is equal to plus or minus. You try to reduce the square root of 3, but 3 is prime, so it stays just like this, plus or minus the square root of 3. We expected 3 solutions. Here's 1. And the plus or minus will give you the 2 other solutions we're supposed to have for this equation.